So guys, in the last class you have seen that how to use SQL. In this class, uh, in this class we are going to dealing with some important lesson about the machine learning, which is called the model evaluation. So I am going to use a new notebook, but I am using the same data set, the IV data set. So it is the name is model. We have decided which model is best with their argument. So we will using. I'm going to write code a little bit faster in this class because most of the things are same. Uh, just one second. So let me write the code a little bit faster. So first line I'm going to write here is the code where I'm going to import the data set. Uh, import iris. Iris dataset is good, is very fantastic dataset. It is easy to understand some functionality of the machine learning very easily by using this dataset. So let me run this cell. Okay, it will allocating the space and all. It will take some minutes. After the allocating and all, it will be start, and you will understand everything. Okay. Now, so I'm going to create a variable called load iris. So this is the varies variable I'm going to add, and I'm going to write two things: iris dot data, it x, and y is for iris dot what level, no level is equal to target. So we already discussed this data set in my previous classes, so I'm not going to deal with again and again. Okay, and because we already deal, so let me write import a model which is I discussed in my last class, which is the logistic regression model, and it is very easy to import logistic regression by using this import this package linear model import logistic regression. So now it is done, and after that we are going to create a variable log res, and we need logistic regression. Okay, now so this time I'm going to pass x and y both, and this is the things. Oh, sorry, not sorry, we have to start logistic regression, and we have to write log res, uh, just one second, log res dot fit is a part of training, so you need to pass the dataset input and output field, and it will start the training. Okay, and if you write log res dot predict, and we need to be x, so this is the output of all the, it is the output of your according to this input, this is the output. So you have been seen already this topic we already seen in my last class, and also we are discussing some train and test and overfitting part in my last class, but this type of thing we will discuss later. We already discussed in my previous classes. So now we are dealing with the what is the meaning of evaluation metric. So that this time you see the, you have to understand the accuracy. So suppose you will be a store everything in a y predict, and this is the y predict is getting from log res dot predict and passing the x value. So it is meaning this is the y value is a real value, and this is a prediction of all the value. So we are going to check the accuracy very easily. So you have to import scalar, you have to import scalar, and from scalar you import, just one second, accuracy score, and just print the accuracy score which is getting from real value and prediction value. Okay, and prediction value. If you see this accuracy, this value is coming something like 97%. Yeah, it's good. 97% is good. So in the last class, you have done the logistic regression. Same as logistic regression, there is one more model. It's called the KNN, K nearest neighbor. Basically, K nearest neighbor is generally used for the classification and is similar to the other classification model. And if you comparing the K nearest neighbor model with logistic regression model, it is a cost effective. Means it will for training the model, time taking is too high in KNN over the logistic regression. So I'm not recommend you to use KNN every time, but KNN return result good in a different way. So how the KNN work? So let me explain the KNN part. Basically, the KNN work is something like that. Suppose this is your data set. This is the graph of data set, and there are two type of data. One is black, and one is suppose green. Okay. So two data set are there, and suppose there is one data you want to predict. Means you are going to predict this data. So suppose there is this point, this. So if you are going with logic regression doing what? It is creating a simple, it is creating classifier, something like that. This part is black, this part is red, this part is green, and this point should be green according to logistic regression. Okay, okay. But in the KNN, K nearest neighbor, it's working differently. How this K nearest neighbor? So let me erase this line first because we don't need this line. Okay, how the K nearest neighbor is work? So how the K nearest neighbor is? So K nearest neighbor is working something like that. First, suppose you're passing KNN. So here K is a parameter. Guys, K is a parameter. Suppose you're using K is equal to 5 or K is equal to 3, whatever the number you have selected. So for K is equal to 3, when you choose K is equal to 3, it is meaning you are going to select 3 nearest point. 3 nearest point. So suppose the 3 nearest point is 1 point, 2 point and 3 point. So this is the sum, this point and this point and this point. This is a K third 3 nearest point. And because you selected the 3 point, after that you see which point is more common. So here you see the green is more common. Green is more common. So that's why this point should be green. This point should be green. Suppose there is other point is there like okay, suppose this. Suppose we are going to say K is equal to 10. So you are going to select 10 point. 10 nearest point. The first point is selected like this point, 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 and this point. So 1, 2, 3. If you see which is the most common right now, this red point is nearest to green, but you are using K equal to 10. So you are going to select this point, and you see most of the point are black, means 1, 2, 3, 4, 5, 6, and 6 point are black, and only 3 point are the green. So that's why this point should be black. So KNN is similar or working like that. Guys, are you understand what is the meaning of KNN? K select the nearest point, and after that it will select like most common point. According to most common point, this is your prediction. Clear, guys? Yes or no? At least say yes or no. Are you able to understand the KNN model? So I'm not going to write this code in a scratch. Yes, we can, but I'm not going to write this time on the scratch code. So I'm directly use the scalar. So how the KNN is work? So KNN, suppose I'm going to use KNN with K is equal to 5. Suppose I'm going to write. So now I am going to write from scalar neighbor. Just one second. Okay. Classifier. Just one second, guys. Please wait. I need to make a call. Hello, guys. Am I audible? Yes or no? Please say. Hello. Hello. Thank you. So you see, so this time I am using k nearest neighbor model. This k nearest neighbor model is working with the nearest point. So now, guys, this point is clear. So KNN model. So now next we are going to use KNN, and I am going to use k nearest neighbor classifier. Sorry. And here I am going to use a attribute five. Okay, here is this argument tell we are going to use the k is equal to 5, and now the data set is this. So we are going to k and then fit, and I'm going to pass x comma y, and again we are going to y predict, and we are going to use knn dot predict, and I'm going to pass x and print accuracy score. Okay, so this time kn is equal to 5, and you see the accuracy score is 96. Yeah, it is not better than this, but it's 96. Okay, now just copy this stuff, paste it again, and I'm going to use kn is equal to 2. So this is 98. It's much better than this. Now kn is equal to 1. Yeah, it 100% accuracy. Yeah, 1 is not good. Generally we are not going to check kn is equal to 1. Now, so you see this lots of k. Suppose we are going to pass kn is equal to 8. The problem is you are going to train the model. It's good, but the problem is we don't know which k is best. We don't know which k is best. Okay, we don't know which k is best. Now again, suppose this time you are training the model and testing the model on the same data set. So this is not good. So I am going to first split the data set, and then again I am going to check the model. So from scalar model selection, import train test split. Okay, so guys, you see after the train test and split, now I am going to pass x train, x test, y train, and y test, and this is getting from train test split and passing x and y. So this will be like divide the data set in two part, train part and test part. Generally bigger part will go for the training and the smaller part will go for the testing. Now see, yes, I am sharing, or only you or other people. Okay, don't worry about it, don't worry about it. Let me share it again. Just one second. Now you are able to see my screen. Garima, are you able to see my screen? You are still, and other people, Himanshu, Mohan, you are. You are able to see the screen, na, Himanshu? Garima, I guess this is a problem from your side. Try to join. Please go. Okay, you have to like uh, go out from this Google Classroom and Google Meet, and then you again rejoin this Google Classroom. Rejoin the Google Meet, not Classroom. No, no, no worry. If you are not able to see my screen again, please let me know. This time you are able to see my screen. That's good. So now you see this x and y. So after the training, let me see the shape. So guys, I'm going to check the shape. Let me use the print because we are going to print two things. So see, you are getting two type of dimension 112 and 38 rows for the testing data set. So now let me see, on everything is same, and this time I'm going to copy this stuff. I guess this type of thing, and this time you have to change X train, Y train, X test, Y test, and now see the prediction accuracy. This time you're seeing 92% accuracy you are getting after the getting the data set of this. Now check it with different K. Just 1 second. Hello. Right now it's clear. Okay. So I don't know why this every time we are saying the same accuracy. 92, 92. I know. Just 1 second. It is impossible. Okay, now it's getting different. So here see the sometime 94, 93. So we not able to understand which k and which k value is best. So that's why we are dealing with something to check some value of k. So that's why in the next line of code on the next cell I'm going to write some code where you can understand that how we get the model equation. So for that I am going to testing from k is equal to 1 to 25, and then you can understand which k value is big. So now suppose I am going to store all the k value, k range this value, and I am going to make a list, and it is getting from range function, and range function 1 to 26. So basically this function will return a number of collection starting from 1 and going to 26, but 26 is excluded. Now this is ready. If you see k, just 1 second, I don't know, just 1 second, just 1 second. Hello, still it is lagging. Hello. Okay, thank you guys. If you are facing this lagging also, please let us know during the class. Don't worry about it. I don't know, this is happening in the last 3 to 4 days in my meeting also, because I guess there is some issue in a Geo fiber. We have to contact the Geo fiber team. Okay, now so let's see k range. So here is the guys, this is all the k value means 1 to 25. So we are going to use this all the k value and see which k value is better. So for that I am going to create one more variable where I am going to store all the score, all the accuracy score. Okay, so now I'm going to use simple k in k range and print k. If you see this code, if you run this code, every k will be printed by one by one. So same thing guys, I'm going to create knn, and then I'm going to use, this time we are going to pass k, we are going to pass k, I mean k here is a dynamic, and then we are going to fit and pass x train, y train, and kn we are going to create accuracy score and pass y test. Just one second everyone. मैं ऐसे मैं okay, anyway, so here we are going to pass what vibrate. So and I'm going to store as a score, and after the getting the score we are going to be a score dot append. I am going to part this score. So instead of adding this directly, I am going to add this. Okay. Okay. Now after the add that, if you run this, if there is no error, so here this score value, if you print the score value, so see the number here, different number are getting. Okay. And so here the different score are getting 92, 93. So different number is getting. So it is very difficult to understand which value k is getting the best accuracy score. So that's why we are not going to print this score. We are going to plot this score. We are not going to print this score. We are going to plot that score, and that's why we are using one more library like from mat plot lib dot pyplot as plt, pyplot as plt, and we are going to add. Okay, so plot all the k value range, and also we are going to plot the score, and after that from actually just one second, from mat actually import, and after that plt dot what x label, and in the x axis we are going to be pass the x score or accuracy and value of k, and plt dot so now let me run it. Okay, so this type of graph you are getting. So here this is the accuracy in the x axis. Oh no, just one second, it is like reverted. Okay, so you see, you can understand for the which value k this model is getting the better. So you see, if you are choosing the getting the value of k is equal to 10 or k is equal to 16 or maybe k is equal to 6, then that time your model is getting the better result. That time your model getting the better result, and we can understand, oh, for that model this is the final model, means we can consider that knn for this data set knn is 5 is good, knn 7 is good. But guys, this knn value is this graph is only good for this data set, not for the all type of data set, not for the all type of data set. So guys, you have seen this how the model evaluation is work, and we are dealing with this model very easily like this way. So I hope you understand why model evaluation is important. Model evaluation is important because sometimes you don't know which argument is better for particular model. So not only the training part but also focus on this part, the argument part. So this is the part we are cover the model evaluation, and the next class, which is very important class, because after this class we are going deep dive in the deep learning part. But deep learning part is only those students who can only understand deep learning, who is able to understand logistic regression, who is able to logistic regression from scratch. If you are not able to understand the logistic regression, it is very difficult to understand the deep learning. Also, we have to understand this graph, which I discussed in my first day of class. This graph, like input output decide the program, and you come with new input and you will get the output, and here somehow you will get the model. So in the deep learning part, everything is like different, but the concept is same. Deep learning is not a new topic. Deep learning is a subtopic of machine learning. But I'm trying to make you understand very easily, that you understand every point. Every concept should be clear in my deep learning part. So guys, if you have any query to this model evaluation, please let me know. I know this part is easy, but this part is a topic that we have to understand. And when I deep learning, and also guys, I'm using TensorFlow for writing the deep learning code. So this class is also important. For further class is also important because we are dealing with the TensorFlow things. In my upcoming classes, I will also guide you how to create a model, deep learning model or neural net model from a scratch Python. We are dealing this type of thing in my upcoming classes. And after today's class, your upcoming classes will be little bit going faster. I'm not going to write every line of code from my hand. Maybe I will copy paste the code, but don't worry, I will clear the concept every line of code which I'm going to write. If you are able to understand, if you are not able to understand any point in this till this point, please let me know. Any line of code you are able to understand, you are facing problem, please let me know. Himanshu, Hushain, and Akanksha, Garima, Goswami, if you are facing any issue, please let me know. And guys, I'm going to share the code, and please guys, I share every code offline in my all the previous classes. So guys, please go and check it out, what is the things is I'm going to teach. Try to write the code in your notebook, this will be better. And now I recommend you to don't copy and paste the code. Try to write the code line by line, at least that code which is the logistic regression code, which is written by the scratch Python. So code is very important. So where is the share button? Copy this link. So I'm sharing this in a Google Classroom, and